Hi everyone, welcome to Brilliance classes. So in this video we are going to see some more questions based on op-amp. So I have already uploaded 2 more series based on this. और अगर आप लोगों ने वो वीडियो नहीं देखी है तो प्लीज़ जाके प्लेलिस्ट में चेक करें. So we will start with the very first question, that is here we have given a circuit and we have to find the current IL across the resistance RL. सो लेट अस सपोज दैट यहाँ पे जो वोल्टेज है उसको मान लेते हैं कि V1 है. सो द वोल्टेज हेयर इज़ V1 एंड ड्यू टू वर्चुअल ग्राउंड द वोल्टेज हेयर विल बी ऑल्सो V1. सो अप्लाइंग यहाँ पे भी वोल्टेज क्या हो जाएगा, V1 हो जाएगा. सो अगर इस नोड पे अगर हम लोग KCL लगाते हैं तो क्या हो जाएगा, V1 माइनस V बाई R प्लस V1 माइनस V नॉट बाई R इक्वल्स टू ज़ीरो. मतलब यहाँ पे जो भी करंट है वो क्या हो जाएगी, सारा सबका सम क्या हो जाएगा, ज़ीरो हो जाएगा. सो फ्रॉम हेयर वी कैन राइट 2V1 बाई R इक्वल्स टू V नॉट प्लस V बाई R और 2V1 इक्वल्स टू V नॉट प्लस V. नाउ अगर हम लोग यहाँ पे इस नोड पे अगर KCL लगाते हैं तो क्या हो जाएगा, V1 बाई R प्लस द करेंट अक्रॉस दिस इज V1 बाई RL एंड द करेंट अक्रॉस दिस इज V1 माइनस V नॉट बाई R एंड सबका सम क्या हो जाएगा, ज़ीरो. Now from here we can write 2V1 by R and V1 by RL is actually IL. So plus IL minus V naught by R equals to ज़ीरो. सो यहाँ से अगर हम लोग देखें तो 2V1 equals to V naught plus V है. So from here we can write, instead of 2V1 we can write V naught plus V. So V naught plus V by R plus IL minus V naught by R equals to ज़ीरो. So V naught by R and V naught by R is cancelled. So from here we get V by R plus IL equals to ज़ीरो और IL equals to minus V by R. So this is the answer. So the current across this IL is equal to minus V input voltage by R. Now the second question is, we have given a circuit here and we have to find the output voltage V0. So we know that in case this is a case of inverting amplifier, and in case of inverting amplifier the output voltage is given by minus Z2 by Z1 into Vi, where Z2 is the feedback impedance and Z1 is the input impedance. सो यहाँ पे Z2 क्या है, 100 किलो ओम मीन्स 10 की पावर 5 ओम. और अगर Z1 की बात करें तो Z1 कितना है, 1/SC. दिस इज़ अ कैपेसिटेंस, सो 1/SC एंड 1/C की वैल्यू क्या है, 10 माइक्रोफैराड इंटू 10 की पावर -6, यानी ये क्या हो जाएगा, 10 की पावर 5/S. सो अगर इसमें वैल्यू पुट करते हैं तो क्या आ जाएगा, V नॉट इक्वल्स टू माइनस Z2 इज़ 10 की पावर 5 ओम एंड Z1 इज़ माइनस, दिस इज़ माइनस 10 की पावर 5/S इंटू Vi. सो V नॉट इक्वल्स टू माइनस SVI. So this will be the output voltage across this. Also we can see that here a capacitance is connected in series with the input voltage. So this circuit will act as a differentiator. So this is the actually a circuit of differentiator, and the output voltage is given by V naught is equal to minus Vi and minus s into vi, and if we take the inverse Laplace of this, then s is replaced by d vi by d by dt. S is replaced by d by dt. So v naught equal to minus d by dt of vi. So this is the circuit of a differentiator. Now the second question is, an op-amp having a slew rate of 62.8 volt per microsecond connected to a voltage follower configuration. If the maximum amplitude of the input sinusoidal voltage is 10 volt, then the minimum frequency at which slew rate limited distortion would set in output is. So basically slew rate होता क्या है? It is the maximum change in the output voltage with a abrupt change in the input voltage. मतलब कि हमारा op-amp कितने fast respond कर रहा है, and it is given by slew rate is given by dv naught by dt, that is maximum change in output voltage, and it will be maximum. So suppose अगर v naught हमारा क्या है, v sin omega t. So we have to find d by dt of v naught. So d by dt of v naught is v into sin ओमेगा को अगर डिफ्रेंशिएट करेंगे तो क्या आएगा, cos ओमेगा t into ओमेगा, and we have to find the maximum value. So the maximum value of the cos function is 1. So from here dv naught by dt equals to v into ओमेगा, and dv naught by dt actually में है क्या, that is slew rate. So from here we can say slew rate equals to v into omega, and omega को replace कर सकते हैं 2 pi into f. So यहाँ से क्या हो जाएगा, f equals to sr upon 2 pi into v, and v is the maximum or input voltage. Now in this question the value of slew rate is given as 62.8. So in case of in this case the value we will put is 62.8 volt per microsecond, means upon 10 की power minus 6 second into 2 pi, and what is the input voltage, that is 10 volt. So it will come as 62.8, and 2 pi into 10 is 62.8 into 10 की power minus 6. Now this will get cancelled, और यहाँ पे क्या आ जाएगा, 10 की power 6 hertz, और we can write 1 megahertz. So the answer will be 1 megahertz. So the slew rate is the maximum change in output voltage with respect to time. And in case of 741 op-amp, generally the value is taken as slew rate value is taken as 0.5 volt per microsecond. Now the last question is, we have given a circuit consisting of 3 op-amp and we have to find the output voltage V0. So suppose let's say the voltage is V01 और यहाँ पे क्या है V02. So firstly we have to solve this op-amp and find the value of V01. So this is the case of inverting amplifier, and in case of inverting amplifier the output voltage is given by, that is V01 is given by 1 plus R2 by R1 into Vi, means 1 plus R2 is 100 and R1 is 10, and the value of Vi is 1 millivolt. So it is 11 millivolt. So the output here V01 is 11 millivolt. Now in case of V02, this is the case of inverting amplifier, and in case of inverting amplifier, the output voltage is given by minus R2 by R1 into V01. Minus R2 is here 470 by R1 is 47, and V01 is 11 millivolt. So it will get cancelled and we will get minus 110 millivolt. So the output here is minus 110 millivolt, and it will act as the input to this amplifier. So now my third amplifier is also a inverting amplifier. So in this case, the output voltage V0 is given by minus R2 by R1, that is minus R2 is here 22 and R1 is 2.2 into V02 is minus 110 millivolt. So minus minus will get plus, and 1100 millivolt, or we can write it as 1.1 volt. So the total output voltage across this is 1.1 volt, and this is a plus.